Okay, so the question tells us to find to determine the area of the region which is bounded. So the area would be the area between these two and bounded by these two restrictions: y equals -2, y equals 2. So the way you solve this is that you have to make this sort of an integral. So the area would be equal to the sorry, people are racing outside. I don't know what they're doing. With the definite integral of 2 over -2, and then it would be these two functions, y plus, it would be be y squared plus 4 minus 3 minus y squared, which is just this value right here. And so we just solve for this and we get our area. Not that hard. So let's get into it. So then we can separate these two into two separate functions. Or sorry, no, we just simplify this first. So this is going to be 2 equals 2 -2. And then this simplifies into 2y squared plus 1 dy. And now, see, all I did is distribute this and just add like terms. And then we can separate this two separately. So it'd be 2y squared plus derivative of 1y dy. And so this would end up to become the 2y 3 over 3 with the restrictions of a -2, sorry, 2 over -2, plus this will become x if you find the derivative. Oh, sorry, y, since we're dealing with dy. The integral of 1 would just be y. So y over 2 over -2, sorry. The smaller one's always at the bottom. And so all we have to do is just add, just now, we just use substitution. So now we get, this would be equal to 4. And then with this, it'd be 2 times 2 to the 3 over 3 minus 2 to the -2 over 3 is 3. And this is equal to 32 over 3 plus 4. And this will give us our value. And I already have calculated this separately. I mean, you can pause the video and do it. And so the solution is 44 over 3. This is the area of this is what am I saying? This is the area of these two functions bounded with these two restrictions. This is another way of saying -2 over 2, by the way. As if you might see this function more than you might see this. And so essentially you're just subtracting these two functions. You're subtracting this function from this, because this one's of course a larger function. It's kind of like regular subtraction.